Okay, perfect. We are on the roll. Hey, folks, thank you so much for joining on a Friday evening. I'm sure you have to party in a few hours, but yeah, just like stay for this 1 hour and learn some cool things from Abhishek. So, quick intro, I'm Harsh, founder of Tech Career. We are building modern recruiting platform, helping connecting talent with companies. And Abhishek, he's a friend I made through Twitter. We met in Bangalore 1 or 2 months ago, and he happily agreed to do this fun 1 hour session on Langchain. So, if Langchain you haven't heard of, is kind of like a Swiss knife to build LLM powered apps. And Abhishek is a software engineer at Observe.ai. He his day to day is around AI apps, and before that he was at a finance platform, and before that with Swiggy for about 2 3 years. So yeah, welcome again, Abhishek. And yeah, on to you.
Yes. As Hers already introduced me, so I will just start with uh, the thing and I came here for. So first, I will start with Langchain, what it is. So basically, Langchain is an open source library which you can use to call LLMs. So why it is used is suppose you have a backend application which calls suppose Chat GPT API or Claude API. So you don't want to be dependent upon a single LLM because every day new LLM keeps popping up which is better than the previous one. So you want to keep changing whichever is the best one. So using LangChain, like you don't have to be like LLM agnostic, and you can just use the LangChain API, and it internally calls the whatever LLM you want to use. Just change the import and everything. And so like this is just a basic introduction of LangChain. And so I will just show you how you can build like applications using LangChain. So first, I will give an example of how Swiggy built Harness. I will tell you what it is, and they recently open sourced it as well. So let me just share my screen. So I think you can see my screen. Um, just,
Yeah.
so what Harness? When I was at Swiggy, yeah. So when I was at Swiggy, so there were a lot of analysts. So they used to crawl as our database and see what are the ordering pattern is, what kind of food people are ordering, what are the order values. So after the LLM came, the product managers wanted to do it on their own instead of asking analysts. So they asked the data science team to build some application where they can just write something, write in natural language, and they will get the like the graphical representation of the order values and everything. So the data science team came up with this tool where you just have to write in natural language what is the order value on this day, or which was the like most ordered food on last uh, new year or something. So how it is built is let's go to the technology aspect. So so how many of you know like what how LLM works? Can we have a poll here? Harsh, are you there?
Yeah. Um, do you know how LLM works? Or also you can just like yes or no in the chat.
Just
Uh,
showing hands up like
yeah.
uh,
The poll is also live, or just feel free to raise your hand or drop a yes on the chat. But few people know, I think 3 5 people know.
okay. Okay, so I'll just give a basic like understanding of how LLM works. So so when you give an input to the LLM that what is your name or something, so it converts the natural language into tokens or numbers. So as computer don't understand strings or English language, so it converts into as tokens, numbers, and it creates relationship of the numbers inside it, and it compares with the relationship and returns you the token it is like mostly related to. So it is just a vague understanding. So similarly, like just don't look at the whole image. I'll just show you what how it works. So we have this database, and we so a database has tables, tables has columns, and columns has types, right? So in short, database has tables and tables has metadata. So we store all the tables metadata into a knowledge base, and we are not storing it as a string. We are storing it as embeddings, or you can say uh, we are converting all the data, our table data, into numbers and storing the relationship of the numbers, because Swiggy has like thousands or 10 thousands of tables. So storing it as a string and querying the LLM will be like too costly to run the query. And so here you can see uh, we have knowledge base where the embeddings are stored. So whenever a user gives a prompt that please generate this SQL query for this suppose order value or average order value, then it will take all the table schemas or metadata. It will give it to LLM, and it will also give the user's prompt to the LLM that this is the tables metadata and user want to generate SQL query for this, and it returns a SQL query, and it checks for the syntax it is correct or not, and then execute the query, return the result. So we will do a similar thing, but on a smaller scale, because we don't have like thousands of tables and all. So I'll just show you how you can do it. I'll just share my screen, I believe my VS Code is visible.
Yeah.
Yeah. So I have written this code like yesterday, so it might have bugged or something. So I'll just delete this TV. So everything is done through Langchain and ChatGPT. I mean the ChatGPT API. So I will also show you how we are generating the data. We don't have a table right now. So I have also written this mock generator which generates all the tables, all the data. Basically, a mock for your testing. So I'll just use it. I will also go through the code how it works. So suppose I want to generate data for a sector of suppose restaurants, and our data our database will be SQLite, because it is very easy to test with. Just the use case can be and it will ask, it will check with the LLM that these are the like things user want to generate the table with. So it will give it suggestion, and it gave the suggestion that we can generate table for these following, and I will just do yes. And it will generate the table, it will generate the data, and it will insert in the database. And this like code is independent of the like sector. It can generate any data, because LLM can do generate any type of natural language. So uh, let's wait for it to get completed. So you can see we have bookings, customers data, all these are mocks, no basic restaurants, reviews, and tables which are available. And first, I will demonstrate it how it works. Then we can go into how it works. Then we will go into the details. So you can see we have this basic prompt that which who visited the restaurant with the highest rating and what did they say. So we'll just execute this code. So you can see ALS Smith visited the. Uh, I think this prompt is not like is vague, but you can see it's still like a highest rating had given by was given by ALS Smith, and he had written amazing food and great service. Like we can also write something like which is the best. Let's also print the SQL query we are getting. Okay, so you can see this SQL query which is generated by the LLM, and uh, I think this is the restaurant name, the Gourmet Kitchen. The rating is 5, and I think this was given by Ellis Smith. And so let's get into the code. I will not be live coding. I will have written the code already, and I'm just showing. I will just show you how it works, because it takes a lot of time. Googling to write the code and everything. So let's dive into the code directly. So we have this. We will start with the this DB code first. How it works. So like I think everybody is like familiar with SQL and like database querying. So let's just see the code. We have this function get all tables, which suppose we have this database and it has like 5 tables. So this is a basic base SQL query which returns the all the table names as a list. I mean, this function returns the table names as a list, and we have this function get table schema, which returns all the column name and the column type of each of the table. Suppose we have this. Suppose we pass table name as bookings, so it will return all the column name, and the type of this column is like integer or string or dates. So we have this function, and here we are just iterating through all the table names, and getting all the schemas together into an array, or and then returning it. And we are just formatting all the data. I mean, concatenating all the strings into a single string. Suppose we have this database, so it will just take table name bookings, and it will just list all the uh, table metadata like column name and column type, and it will do for all the tables. And we are just storing it as a string. But earlier I said Swiggy Hermes is using embeddings, so they are converting all the strings to vector embeddings, because they have like tens of thousands of column data. So it is not possible to store it as a string and give it to LLM, because you might have heard about LLM token sizes, token limits, like input token limit and output token limit. Chat GPT has around one, so it varies depending upon the model. So I think Chat GPT 4 has around 1 lakh token limit. So you can say one token is around one word, like approximately one word. So you can say you can like fit 1 lakh words into a single input, and that is also very costly. That will be also a costly call. So, and we don't have that much data. I'll just show you how. Yeah, hey Amit.
Hello, hey Abhishek. So I wanted to ask, if I'm creating something like maybe you have heard of super memory. So if I'm, have you? It's like you put your thoughts into that and it stores your thoughts, and then you can chat with your thoughts anytime.
Yeah.
So my question is, if I have stored a lot of thoughts in there, a lot of text in there, and I'm vectorizing all the embeddings and storing it somewhere, maybe a vector database, of course. And when the user wants to chat with its own memories, then I would most probably would store those.
Can you
I mean, I will
like
retrieve.
Just like, can you put your question in comments? I will just go through it last.
Sure, sure, sure. Got
Yeah.
it.
Okay. Thank you. Yeah. So I was saying we are just storing all the table data as string, not as embedding, because we don't have that use case. But if you are building at scale, you will have to vectorize all your data and store it into a vector DB. So I will also show how our output is. So you can see how we are storing all the strings, string like this, and giving it to LLM. And so we have all the schemas, and we are using Langchain here. So I will just go through this code right now. So as I have already been through this database code, client database, and we have this chat OpenAI, which I have imported from Langchain. So you can, if you're not using chat OpenAI, if you're using Claude or Gemini, you can just import it and you can just pass it to this function and it will work because Langchain is not like LLM agnostic. So we have this function, class. What it does is, so we are executing this do action, so which is just taking our prompt and passing it to this action. So what it is doing is we have a prompt. So you might have heard prompting, giving LLM some prompts. So we also have a prompt template, which I will just show you. So this is our prompt template. So it just says it says to the LLM that you are a virtual agent and you have like you have some work to do. You have to generate some SQL query and do action on some database. You have to just give what you want from the from the agent, and give the commands and give some example that how you will give the input and how you want the output to be. And suppose you have given all these data to LLM, it will return it as a string, not some JSON query. So you'll have to parse it. So here also we can use Pydantic parser, which takes your string output coming from LLM, and you can parse it. And suppose you can give a prompt. Suppose I have given it here. We have this parser which extends this base model coming from Pydantic, and you can just describe that this is a SQL query, and uh, you can also have some fields like you can, yeah. So you suppose you have passed some data to LLM, you are fetching all the uh, keys from the LLM, right? So you can just take it, take the response. It just I'm just figuring things out. Yeah. Okay. Yeah. Suppose you have like called the LLM with the prompt given, and you want the response as SQL, not as a string. So you can use this Pydantic parser, and so you can see we are just parsing it here. So we are just chaining our we are just passing this prompt to the LLM, and know our output of this prompt template to LLM, and then whatever LLM is giving the response, we are parsing it, sending into parser, and we have this chain, and we are just invoking all the chains together. So this syntax is from Langchain, and we are just returning the response. So it returns an object because we have parsed it as an object, and it just returns the response, and we are just getting the SQL response and just printing it. And also you can have suppose you are chatting with LLM, right? And you have given all LLM already has your table schema, so you don't have to give it again. You can store the responses as in some history, and the system message also as a history, and all the history is sent to the LLM again and again, and it fetches the previous data as well. So yeah, so this is basically how it is built, and we have this mock generator which works similarly. So what we are doing is we are just getting these inputs from the user and just creating a database of SQLite, and yeah, so we are just creating a template. So we have a similar template here. This is the whole template, which is similar to the template I shown before. So it just says you are a senior engineer because you want the like column suggestion or schema suggestion based on a good like experience in engineer level, not some junior level. So give the this is the sector and everything. So this is just prompting, nothing like you just have to give like strict instruction to the LM, and give all the fields to the so we are just formatting the string here. We are just calling the we are just sending this prompt to the LLM and getting the response and sending the history just to tell the we don't need to tell the LLM again that what the columns were generated and what the data we have to generate now. So we have all the columns generated, and yeah. So let me just figure it out. Yeah. So suppose everything, all the columns are generated, then we are just generating the data. We have again a template for this. We are again templating. Uh, it says that you have all the column names. You have to and you have to generate the data for the columns, and yep. So this is the thing we are doing here. So right now, I will just move to the comment on questions, chats here. Also, so if you don't want to code like this, suppose you are building apps, you are a backend engineer, front end engineer, and you don't want to code it from scratch. Uh, there are Langchain libraries, built libraries built on Langchain, which is like no code. No, sorry. So there are already libraries built top on the Langchain where you don't have to code. You can just drag and drop and build flows. I will just show one of the tool which have been using recently. Oh yeah, so you can see this. So flow-wise is so flow-wise is also one of the library which is built on top of Langchain, and it has all the functionalities of Langchain, but you don't have to write any single amount of code. And we'll just show one of the template I was using. So I have downloaded this template from the marketplace. So people can create their own, like flow-wise template and upload it on the marketplace, and anyone can use it. So for the showcase, I have just downloaded this, which with just to use what it does. So it makes a chatbot out of a README, GitHub README. So if like if you're seeing the first time, you might feel little like this thing is complex, but this is like very simple one. So we just provide the repo link here. I have passed the public APIs repo readme here, and it what it does is we have this tool. So it reads the whole readme and creates a chunk of like 4,000 words out of it, and downloaded all the chunks into it. And we have this in-memory vector store. So I have deployed this on a EC2 instance, and we are storing all the README chunks in our uh, EC2 instance only, and we are using OpenAI embeddings to embed all the README chunks and storing in our, then again getting the response in our vector store only, which is hosted on our own instance. And as the chain I was using earlier, prompt chain, uh, this thing also has the same things. All the chains you have. So earlier we were using this simple LLM chain. We have this conversation retrieval QA chain here. QA is just question answer chain, and you can just chat with it. So I think the last time I was using it, I think the EC2 instance got some issues because it was running on base, very less RAM. So you can see, you can just query it, and it will return responses based on the README you have given. You can just you don't like if you want to build AI apps uh, with speed, you can try this. This is very cool thing. So yeah, mm, that's about it. If you have any question, you can ask right now. We give all the resources in the comments. Anyone has any questions?
I think we can go through the questions on the. I think some people have answered some questions on the chat also, but we can also like talk through them to get your thoughts also.
Okay.
Uh, yeah. So first question was from Risha. Like, how do I judge what LLM, whether GPT, Claude, Gemini, works best for my particular use case, while considering the pricing in mind? So how do you evaluate what's the perfect LLM for your use case?
Okay, so my personal choices, I just Google, benchmarks of these LLMs and just see how they have scored basis of, suppose I want to run some mathematical equation, some I want to do some math, I want to generate some math equation. So I see the benchmarks on the math thing, the natural language, how their common senses are. So there are a lot of benchmarks. So you can just Google it, and based on the use case, if you want to get some general knowledge out of it, so you can just search for best benchmark for general knowledge from this LLM. So and just try it out, and just check out the LLMs there, and you can also do your own benchmarking. So yeah.
Makes sense. Makes sense. Yeah, I think if you're making something very like generic conversational bot, that's just like a therapist bot, then maybe you can get away with using something like Llama also because it performs well on that. But yeah, if you ask it tricky reasoning, logic related questions, then better to go for the benchmarks and look at something like GPT, Claude, or those
Okay.
perform
So
better.
I have one instance. So I was working on this voice bot thing. So we were suppose you are on a call with a voice bot, and you are saying something, and it is translated by some automatic speech recognition software, and sent all the words are sent to you in real time. So we were using some LLM to check if the sentences are complete or not. So we were just doing the LLM calls like repeatedly. So we were using, I think, GPT 3.5 Turbo, and it that is a very good LLM. The accuracy is really good, but it was taking around 400 or 500 milliseconds. So what we did was we checking is complete sentence is a very simple thing any LLM can do. So we moved to a very small LLM. Uh, I don't know its name, but it was like very small LLM. The accuracy was not that good, but the speed was very good. So we moved there. The cost was drastically reduced. So you can also check out these things if you want speed, if you want accuracy. Just yeah, these.
Yeah, I think that makes sense. I think there's that whole concept of mixture of models or something like rather than one big LLM, generic LLM that can do everything, like a collection of LLMs that routes based on the domain of the problem.
Yeah.
Um,
And using like Langchain, you can do exactly that thing. Suppose you are using like 10 different LLM for 10 different use case. So I think Langchain is built. So just go through the README and like, um,
so
try
it
it out.
can do that LLM routing based on the
Yeah.
query.
Yeah.
Perfect, perfect. And I think there was another question. Is there any difference when you're using LangChain with, let's say, Python or TypeScript? What would you recommend if someone wants to pick?
See, this is again which language is best first type of question. So you can just use anything. Don't go on which language library is best. Just do like any language work. So if you want to build anything, you can build it in any language. Nothing is best, nothing is fast, nothing is slow. If you're building for your own, unless you are doing it for scale. So yeah.
Got it.
If you, I think so. Simple answer would be if you know JavaScript or TypeScript, use that. If you know Python, use that. So,
Got it. Got it. Makes sense. And like Kirtika asking, what is like, are there any problems that developers face while they use LangChain?
So personally, I was using Langchain, Python's Langchain, uh, Langchain written in Python, and the dependency management was kind of tough. So we were getting a lot of issues. And earlier, Langchain was a different library. They then moved to Langchain core. So I think they should have been consistent on the uh, dependency pattern and their like just be consistent. So yeah, so I'd say कि dependencies management was kind of tough in Langchain.
Got it. Got it. Yeah, I think
Um,
people
Hi,
can.
Abhishek.
Yeah.
Mhm.
Yeah, Harsh, continuing. Sorry to interrupt. I just had some question. Yeah.
Yeah, tell me.
So Abhishek, basically, I'm building this product with my friends only, which is around basically like building something which is complement to LinkedIn.
Okay.
So it's more like they are the AI developers. I'm not really into the development side. I'm just working on the product like side of it too. So like they were telling that as a developer, whenever you are working with the Langchain documents, it's pretty tough to, even find, like you have to go through a lot of documentation, even when you are developing a particular tool or agent or something.
Okay.
And then there was one more problem, which he told that it keeps on upgrading so fast that it's not that stable, the Langchain, and it kind of creates problem for the developers as well as for the organizations. So I just wanted some more like elaboration on the dependency thing you told just now.
Okay. So like, so your what is your like main problem? Like keeping the dependencies together, or like keeping the documentation, or like searching out the documentation, which function does what. So like this is like can you just tell your problems again?
Yeah. So when it comes to the agent genesis, it's a software like which we are building, and basically what we are trying to do is building the copy paste components for the copy paste code components for the developers, to like which they can use to build AI agents or RAG flows. So that is something which we are working on, and it's more like just for the developers, giving them the access key. उन्हें कोई भी, let's say if they want to build a small agent or a tool, they don't have to go through such documentation, and they can just build it by using the code components and tweak it according to their usage. So I was curious to know more about this stuff because that's how we can improve and bring in more features for the software we are building.
So, like, if you want to stick to Langchain, like, if you don't want to stick to Langchain, there are other alternatives as well, Llama Index.
Right.
Like, if you still want to use Langchain, there are like you can use something like Flowwise, which keeps track of the
Yeah.
dependencies of Langchain, and like it keeps track. Suppose Langchain changes something, Flowwise changes accordingly, and just uh, so you'll not face any problem. So if you're having problems with Langchain, you can just use another layer on top of it, which is built on Langchain. So uh,
Okay.
this might not be the perfect solution for you, but no, you can just try different tools if it solves your problem. If you are having some like complex problem with this one with one tool. Yeah.
Sure. Thank you.
Yeah.
Amit has a question. Yeah, Amit, you can go ahead.
Yeah, sure. So I'm building an application where I don't want to lose context of what the user has previously entered.
Okay.
So even if I store that embeddings into a vector database, I would have to keep an mapping of what vector it got generated for the text, so that when the user tries to chat with the application, so I would then query the embedding generated and search in the vector database, and the embeddings I got, I have to then again retrieve the text uh, and then search. And how would I reduce the cost in this scenario?
Yeah, cost. So, see, building AI powered apps is costly. So, if you are like, so you'll have to load the embeddings, to the LLM. Like when I use, suppose I am a user and I have all the chats stored in, some embeddings in your database, and when I log in again, you'll have to load that in the context window. So that if you want to keep it loaded, that will be very costly, because that's why you don't see Chat GPT or any other no chat LLM providers. So they have a chat interface. So you don't have all the chat stored in their memory. So that's the reason that is a costly thing. So you have to do it again if someone uh, logs in.
Right.
Okay, is there a way around to not store the actual text in some key value database?
Uh, I don't know any ways you can do it. So, but you can still look for solutions. I've not done it, so I don't have much idea on it.
I
Sure,
think
sure.
if you
Thank you.
want to do like memory stuff, like just build something simple, RAG. I mean, and usually the text is associated as a metadata with the vector. So I mean, I did this. We had a lot of users. I did this at Banter AI. So we did not store every conversation text. What we did was we just like kept a summary of 1,000 words of the what the user spoke in previous conversations. So that effectively, like we summarized the latest conversation. So the AI felt still personal to the user. So we kept making a new summary out. We kept combining the old summary and the new conversation to make a new summary, and so we kept a summary of 1,000 words. So that was a very middle, like a hybrid way, not storing every piece of conversation, adding it in a vector database, and then fetching it on every conversation dialogue. What we did was just maintained 1,000 word summaries of last conversations, and we removed whatever fluff was that. So let's say we were building like a influencer bot. So if they said, hey, I liked your YouTube video XYZ. Um, so it remembered all of those essential details, and we put that into the LLM call as the personalization. But you can also do that like super memory stuff, right? I think you're mentioning what Dhavya is building, all of that. So you can do that. I think it can get costly when, yeah, like Abhishek said, when you have a lot of users. But yeah, if you want to like really build that, so you can just use like PG Vector or Pinecone serverless. Those are like very affordable solutions. PG Vector, I think with Supabase you might be able to get it for free, and Pinecone serverless you get credits, and it will charge you on based on usage, not like a pod that will cost like $30 per month. And they will give you like $100 credits for Pinecone serverless. So you can store every conversation dialogue with that, and whenever the user asks you something, the it will do a vector search, right? And it will return the vectors to you. And usually the way do you set up is your vector you store in Pinecone has a metadata, and that metadata has that actual text for which that vector was. So you get the vectors and you then get the text out of those vectors which they're associated with, and then you combine them and add them as context to the LLM call.
Got it. Pretty helpful.
We have 5-10 more minutes for questions. If anybody or if anybody wants to like discuss a LLM topic, um, somebody's ending joining towards the very end. Um, okay, LinkedIn for connecting. Yeah, that'll be fun. I'll just drop my LinkedIn. What's and Abhishek, like, what's one thing that you're excited about, like, what to explore in AI next, like multi-agent systems and all of that? Like, there's a whole range of things that people are building.
Right now, I'm interested about audio models, so I'm still working on the audio model, and just want to get into like deeper how it works. See, there are two kinds of audio model. So one is you give it text, it returns a text, and then it converts the audio. I mean, it you give audio to it, it converts into text, then give it to some LLM, return the response, and then convert it to like audio. So that is one audio model. Another is so you give it audio, and it tokenizes that audio and do various stuff on it and return audio response. So, that is one. So I'm interested more on the actual audio model, not the
Or like audio to audio stuff. Like you send
yeah,
in, you get audio out.
right,
Ah,
right.
that way. Yeah. Yeah, I think people are experimenting things like that. I think there was one model. Like usually the way you do is you like pipe up Azure, then OpenAI, and then something like Even Labs to get a AI voice response out. But I think some people are experimenting. You just pipe in the voice and you get a voice out. So that reduces your whole latency.
Right.
Uh, I
And
don't
so
think
Suno AI is doing that. So Suno AI, what it does, it suppose you give some, uh, suppose you give description about you want to write a song, and it will generate a song. So that model just generates audio on the fly. So that is like really interesting thing, like how they are generating audio. They also have emotion in the audio. So uh,
makes sense, makes sense. And I think I was interested in that, like how did you uh, went out and picked a smaller model for that smaller use case? Like I think that's something that I haven't done. So like how do you go about doing that? Like was that like a smaller LLM that you used, or was it like a traditional BERT, or I don't know, some classifier model
so
that you
yeah,
used?
what I was doing is, suppose we were earlier calling GPT 3.5 Turbo. So we were just checking if the sentence is correct or not. So I just Googled around and saw there is this library called Scappy or something. Let me just check its name. Scappy. So it was a like NLP based, I mean, not NLP, NLU based library, which just checks. So suppose you give a sentence to it, and it will, you can just check if it is a, if it has subject, it has verb, it has agreement. A sentence is built up of subject, verb, agreement, object. A lot of things. So I was just checking all these things were there. It has period or not. It has exclamation mark. So I was just checking that, and so I was creating a score out of it. Suppose it has subject, it has everything. So there are sentences which has only two words and it ends there like uh,
I go.
I go. Yeah. So this is also a sentence. So this was failing on that NLU library. So I just created a score out of it, and if the score was greater than X, then I was returning that this is guaranteed a sentence. And if the score was lower than that, then I didn't have had a guarantee that this is a sentence or not. Then in that case, I was passing it to the LLM, the smaller one.
Makes sense, but you're still able to like cut down your cost because
Yeah,
makes sense. Yeah, that's a nice hybrid. Like the LLM is then as a fallback.
Yeah.
Uh,
Okay.
and
So
what's the
so are
latency was for the LN
so
NLP approach? I think that must have been like super quick compared to that.
earlier the we were getting latency of like 400, 3 to 400 milliseconds. Then it cut down to around 20 or 30 milliseconds.
Yeah, I think that's a perfect example, right? Like sometimes we use LLMs. We, I mean, now that LLMs have become so big,
Yeah.
so now we're trying to use them for everything. But like things are these are examples of where the traditional approaches still work very well.
Correct.
We can save time on compute and costs and everything. Like I was trying to build, like a scraper, and I thought I use the function called say parse the title, description, and everything. Like that's such a not great way to go about it because traditional scrapers are still great. Um, Probably a better approach is to like make the AI write a scraper, but not use the AI to scrape every page. So I think, yeah, with this like modern age of LLMs becoming so cheap and things,
Right.
we'll have to keep be mindful about like if we are using them as an overkill or not.
Right.
Um, we still have like 10 minutes left, but we can close early if nobody has any questions. And have you done any like fine tuning and those things? Like how do they work?
I don't exactly do fine tuning. Like, so we have another team who uses open source model, fine tune it, and deploy it. Or like sometimes we also use Bedrock, fine tune there. So if we have a lot of tools where you don't have to put a lot of resources, so just use AWS and get away with a lot of bottlenecks.
Got it, got it. And I think you have to like build like when you like I mean I'm an indie hacker style person, right? Like I don't use any monitoring tools or anything with my AI stuff. So like what does the production environment look like? What sort of tools? Is there a guideline or recommendations when you're building AI apps for your company?
So right now we are in the alpha stage. So my team is in alpha stage. So we just build randomly, deploy it on Docker on EC2 and just get away with it. But if you see our main products environment, it is like very secluded. Uh, we have a lot of compliance due to our data. So we just no, like if we are using third-party services, we ask them to give us a Docker instance. I mean a Docker image, which we deploy it on our server, not their server. And because data leakage is a very like big thing in AI. So uh,
Got it. So yeah, okay, I guess the mandate is to run everything on premise then.
on.
Makes
So we use like ASR applications. So there's this DeepGram.
right.
There's this startup called DeepGram. So they're also like quite big,
Right.
and they do speech to text, text to speech. So what we did earlier was we like asked them to give us Docker image. So they generally don't give, but they had because we had compliance issues, so they gave us the Docker image. So we deploy it on our own services and use it directly. Most of our services are like this only.
Makes sense. Makes sense. Yeah, I think it's also better for their pricing. They're able to charge more with this.
Yeah,
11 Labs also has some on-prem stuff, and they have these very nice one-liners to like provision infra.
yeah,
But yeah, but getting the GPUs is harder than to get these on-prem services because to run these also you need heavy GPUs.
yeah.
Makes sense. Cool. I think we don't have any more questions from the audience. So thank you so much everyone for taking the time on a Friday night, go out party, and we will email you the recording and the GitHub repo probably by tomorrow or Monday. Yeah, thanks for doing this, Abhishek, and yeah, nice to have you. Thanks for joining everyone.
Bye.
Thanks a lot.
Thank you, Bhushan. Thank you
Thank you,
all.
guys.
और भाई कैसा था?
बढ़िया था।